Welcome back. In this presentation, we're going to learn about how to append a new value to a linked list. We'll do some visualization of it and then write a Python program to do it. So let's kick that off. In this lesson, we'll start by doing some visualization by showing a 2D array and what happens to the array when we append a new value to the linked list. Then we'll write a procedure in Python working together to append a value to a linked list. And then at the conclusion, there's some further exercises with linked lists in Python that will let you stretch your and show what you can do. So just a reminder of what appending means. Appending just means add at the end. To append a value to a linked list, you have to make a new node that contains the value and then add a pointer to the new node at the end of your linked list, and then the node is then part of the linked list. So in this section we'll visualize it using a 2D array. If you can't remember what a linked list looks like in a 2D array, go back to the first presentation in this series. So here's a simple 2D array. I've shown it vertically this time instead of horizontally. It really doesn't matter. It's the same thing. We just, for convenience, I'm showing it vertically. The first column shows the address of each memory location, and then the next two columns are the two values of the node. The first one's the data value, and the second column shows the pointer value, which is an integer. And this time there's plenty of space, empty, unused nodes in the array. That's so that we can add new values easily. In order to use a 2D array as a linked list, the computer needs to remember two values. We've already spoken about one, the header. That tells the computer where to find the first node of the linked list. It doesn't have to remember any of the other locations. It will find them all by following the pointers. And then when we're using a 2D array like this, we also store the location of the first empty cell, which is typically called free. It's called the free pointer, and it tells the computer where there's some spare space for it to add new values. So let's see how we would use this to make a new node, and then later we'll add the node to the end of the linked list. So we look at the free pointer. That tells us that location 3 is empty, so we put the value, in this case D, into location 3. There isn't a pointer, it's just none. At the moment, there are no changes to pointers. Then we've got to get to the location where we're going to append the data, and because of what append means, that means we've got to get to the end. So we start at the header and then we follow the pointers until we reach a node that has no pointer. It's pretty easy to see on this one because it's such a short list. So we've hopped down, we started at 0, we've hopped down to node 2. Node 2 has no pointer, so it's the end of the list. And now we're going to change the pointer at that node, at node 2. What are we going to change it to? We're going to change it to the free value, because that's where we've just added our new data. So we change the final pointer to the free pointer. And now we've appended our data to the linked list. The program isn't finished though, because we've also now got to increment the free pointer. Remember, increment means add 1. So we increment the free pointer so it's now pointing to position 4. Pretty obvious why we have to do that. If we don't, every time we add a value, it will just overwrite the previous value. So we move the free pointer on 1. It's worth noticing that inside a real computer, there'd be a more sophisticated way for the computer to keep track of where it has free spaces, but this is good enough for now, and it works fine. So just to recap what we did, we made a new node at the position that was shown by the free pointer. We traversed to the end of the list to find the empty pointer at the end of the list. We changed that so now it points to the free node, and then we update the free pointer. So if you feel confident, pause this video, open the Python program that we were working on before, and create an append procedure and use it to just add a node to the linked list. Obviously, in real life, we'd want to be continually updating the list, but that will just give you a chance to practice it. The next part of this presentation, I'll show you how to do it. So if you want to practice without any help, this would be a good time to do it. Because this video got a little bit long, I've split it into two. So go on to the next YouTube video for the Python programming part of the task.